Welcome to video lecture on Numericals of Mechanics of Train Movement Part 3. About the train movement, previously I have already discussed in two lectures what are the effects, what are the tractive efforts actually a train has to face when it's running on its track. And that part has been discussed in my previous two lectures. Myself, Chunun Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrashur Degree Engineering College. In my last two lectures, I have already discussed what are the basic effects and what are the mathematical equations of those effects and how those effects are actually developed and how that can be mathematically developed. The equations of those tractive effects that I have already discussed in my last lectures. In this lecture, I will solve some numerical problem based on those mathematical equations which I have found in my previous lectures, and we will see that how these mathematics can be developed in case of tractive efforts, and it will be easier for us to understand that the tractive efforts when we will solve different numerical problems related to this. So we will go our numerical problems related to this and that we will see here. So let us consider first problem. A 200-ton motor coach having 4 motors each developing 6,000 Nm torque during acceleration starts from rest. If the gradient is 30 in 1000, gear ratio 4, gear transmission efficiency 90%, wheel radius 45 cm, train resistance 50 N per ton, addition of rotational inertia 10%, calculate the time taken to attain a speed of 50 km per hour if the line voltage is 3000 volt DC and the efficiency of the motor 85%. Find the current during knocking period. So here are the values which are given, that is a 200-ton motor and 4 motors in each. It will develop 6,000 Nm torque during acceleration starts from rest. And if the gradient is 30 in 1000, gear ratio given 4, gear transmission efficiency given 90%, wheel radius also given 45 cm, train resistance 50 N per ton, rotational inertia 10%. Then we have to calculate the time taken to attain a speed of 50 km per hour when line voltage is 3000 DC and efficiency of the motor is 85%. And we have to also find the current during knocking period. So let us see the solution. First, the weight of the train 200 ton, then diameter of the driving wheel capital D, that is 2 into 45. 45 cm is also already given, so we can calculate the diameter of the driving wheel, that is 90 cm or 0.9 meter. Second one, percentage gradient. So we can calculate it. It is also given. So from there we can calculate. Here in question it is given gradient is 30 in 1000. So the percentage gradient we can calculate 30 divided by 1000 into 100, that is 3%. Now tractive resistance is given, that is 50 N per ton. Then gear ratio also given 4 and gear transmission efficiency given 90%, that means 0.9. So equivalent accelerating weight of the train becomes WE, that is 1.10 into 200, so 220 tons. So the total torque developed, that is 4 into 6000. It is given that it has 4 motors, each developing 6000 Newton meter torque. So definitely the total torque becomes 4 into 6000, that is 24,000 Newton meter torque. Now tractive effort we can calculate from the mathematical equation, that is Ft equals to epsilon capital T 2 gamma divided by D. So 0.9, 24,002, and the gear ratio value 4, and diameter is given 9. So from there we can calculate the total tractive effort 192,000 Newton. Then let the acceleration of the train will be alpha kilometer per second. Okay. So then Ft will be 277.8 WE alpha. This equation I have already calculated in my previous lecture. So putting these values 98.1 Wg plus Wr, and all the values which we have already calculated now we have to put. So here Ft value we have put it, then the value of We we have also put it, then the value of Wg and value of Wr, all these values we have put it, and putting those values we can calculate the value of alpha, that is acceleration of the train. Okay. Now again we can calculate the time of the train to attain the speed of 50 km per hour, that is dm by alpha. The speed is given 50 and alpha we have calculated, so we can calculate the time is 24.82 seconds. In this way we can calculate those values just by putting the mathematical equations and those values given as per problem. Now the power output for driving the axles, that part we have also calculated in my last lecture, and we are just putting those values of Ft we have calculated, value of 50 is given. So the power we can calculate 266.7 kilowatt, and power input will be power output divided by epsilon m, that is the efficiency, definitely 85% given. So we have put that value, and the power input we have calculated 3137 kilowatts. Next, the total current drawn, that will be power input in kilowatt into 1000 divided by V, the velocity. So we have put all those values and we have calculated the current, that is 1046 ampere. Next we will calculate the current per motor, because we know that there are total 4 motors are there. So definitely the total current per motor will be divided by 4. So it will be 261.5 ampere. So these are the all answers we have already calculated from the given value. Now we will go to our next problem. In this problem, see, first it is given a train is weighing 120 tons, is to be driven up an incline of 2% at a speed of 36 km per hour. If the train resistance at this speed is 2 kg per ton, find the current required at 1005 volt DC if the efficiency of the motor and gearing is 88%. If the current were cut off, how long would the train take to come to rest? So all the values here given, that is weighing of train is 120 ton. It is incline of 2% at a speed of 36 km per hour. And train resistance in this speed হচ্ছে 2 kg per ton. Find the current required at 1005 volt DC. Okay. and the efficiency of the motors and gearing is 88%. And when the train current will be cut off, how long the train will take to come to rest. These things we have to calculate. Okay. So see the solution. First we will calculate the tractive effort putting the values directly in the equation. The equation is Ft equals to 98.1 Wg plus Wr. Okay. So here we have not taken W A part because the acceleration part is not here. So here putting the values of W and G and also the value of WR, we can get the value of tractive effort, that is 25,900 Newton. Now we will calculate the power output from driving axles, and the formula is Ft into V by 3600, and the velocity is given, that is 36 km per hour. So we will put this velocity here and we can calculate the value of power output. Now we will calculate the power input. Definitely power input will be output divided by the efficiency of the motor and gears. Here it is given that efficiency is 88%. So we will divide the output power with 0.88 efficiency and we will get the input, that is 294.3 kilowatt. Okay. Then current required. The required current will be power input in kilowatt into 1000 divided by voltage of the line. So it will be 294.3 into 1000 divided by 1500, that is 196.2 amperes. These are the currents required. So ultimately we will get Ft equals to 25,900 Newton. Power output for driving axle equals to 259 kilowatt. Power input we have also calculated 294.3 kilowatt, and current required, that is 196.2 ampere. Now we will again calculate, that is let the coasting retardation will be dc, and then Ft equals to 277.8 We minus bc plus 98.1 Wg plus Wr. So here we have to calculate the coasting retardation actually. So that value we have to calculate. So for getting that value, all the given values we have to put. So assuming that W equals to 110% of the dead weight. Okay. Actually here we are assuming that it is 110% of the dead weight as the value is not given. So this is the standard one we can consider. So considering that we are putting all these values, 277.8 into 1.11 WBC plus 98.1 into 2 into W plus 2 into 9.81 into W. Putting all those values, we can calculate the value of BC, that is the coasting retardation, and that value is 0.7 km per hour per second. So these are the two problems we have solved here, and I have referred here J.B. Gupta book, and in the books you can get lots of problems, solved problems you can get. I must tell you that you just solve those problems by your own hand calculation, then it will be easier for you to understand all these concepts. And mathematics is the base of engineering, so definitely as much problem you will solve by your own, you will much more understand the physics of that engineering. So you need to solve those mathematical problems related to tractive effort, then you will realize what are the actual situation is happening inside the train. So I will tell you that you just go through any books. I have taken here J.B. Gupta. You can take any other books related to utilization of electric power, and there will be a chapter of electric traction, and solve those problems, and it will be beneficial for you. Thank you for listening my lecture.